Assalamualaikum and hi. In this video, we are going to apply the concept of mutually exclusive events. Events A and B are called as mutually exclusive events when there is no intersection between the two events. The events that cannot occur together, so either A or events B, but not both of them occur at the same time, meaning that A intersect B is an empty set. So the probability when A intersect B is equal to 0. Comparison between mutually exclusive events and non-mutually exclusive events. As you can see here, for mutually exclusive events, the intersection is empty set and the probability when A intersect B is equals to 0. On the other hand, for non-mutually exclusive events, there is an intersection between both events A and B. So, the probability when A union B for mutually exclusive events is PA plus PB. In normal cases, the probability of A union B is equal to PA plus PB minus PA intersect B. Example 11. C and D are two events where P of C is equals to 0.1, probability of D is 0.2, and probability of C union D equals 0.3. So we take out the information first. PC equals to 0.1, PD 0.2, and PC union D equals 0.3. The condition is C and D are two mutually exclusive events if PC union D equals PC plus PD when the intersection is equals to 0. I start with the right hand side. P of C plus P of D equals 0.1 plus 0.2, which is equal to 0.3. So C and D are mutually exclusive events. Question B. Find probability C prime intersect D prime. By using Venn diagram, we can see that both events C and D are separated each other because they are mutually exclusive events. As mentioned in the question, probability of C is equals to 0.1 and probability of D is 0.2. Since the total of probability is 1, therefore, the probability outside both C and D is 1 minus 0.3, which is 0.7. So now take a look at C prime and D prime. Where is the region inside the Venn diagram? C prime means the area outside C. While D prime is the area outside D, including C. The intersection means we have to find the area that both lines are overlap each other, which is outside C and D. Therefore, it is 1 minus C union D, which is 1 minus 0.3 equals 0.7. Now, I want to talk about the concept of exhaustive events. Events A and B are two exhaustive events if union of the sets covers the whole of the sample space, meaning that when A union with B, it is equal to the number for all the sample space. So the probability when A union B is equals to 1. Example 13. A statistical experiment has 8 equally likely outcomes that are denoted by 1, 2, 3, 4, 5, 6, 7, and 8. Let events A as 5, 7, B 1, 2, 5, and C 1, 4, 6, 8. Okay, now let's list down all the information. As we know, the sample space is the integer number from 1 until 8. Part A. Events A and B are called as mutually exclusive events when both of them have no intersection. But there is a common element inside A and B, which is 5. They are non-mutually exclusive. Part B are A and C mutually exclusive? Once again, we have to look at the intersection between both of them. Since there is no intersection between A and C, there is no common element inside both of them. Therefore, the probability of A intersects C is equals to 0, and we conclude that A and C are mutually exclusive events. C. Find the probability of A union C. Since A and C are mutually exclusive, therefore, PA union C is equals to probability of A plus P of C, where it is actually minus 0. So since PA intersects C is 0, so we just have PA plus PC. As you can see here, there are two elements of events A, so 2 over sample space 8, which is 2 over 8 plus 4 over 8, because there are 4 elements in set C. Adding up both of them, we will get 6 over 8, and simplify it, we will get 3 over 4. Draw the Venn diagram. We draw a square first, then 2 circles for each element A, B. Let's insert the common element for both of them. We have 5 in the middle here, 7 just in set A, and 2 just in event B. Now let's focus on event C. Since 1 is the common element both event B and C, so we put 1 in the middle between B and C. The rest of the elements, which are 4, 6, and 8 inside set C. Lastly, we put 3 outside A, B, C because neither A, B, nor C contain 3. Part E. Are the events A, B, and C exhaustive? Now we have to take a look at all the elements inside A, B, and C. From the Venn diagram, we can see that all the numbers from the sample space except 3 is 1, 2, 4, 5, 6, 7, and 8 are elements in the set of A union B union C. So we can see from here the number of elements for A union B union C is 1, 2, 3, 4, 5, 6, 7, and the number of sample space is 8. So they are not equal. Therefore, A, B, and C are not exhaustive.